Welcome to Algebra 1. The learning goal for this episode is how to solve two-step equations. Those are equations with more than one operation or have like terms in them. Let's look at some examples. We typically solve these equations by doing the inverse operation. Inverse is the math term for opposite of whatever we've done to the variable in the reverse order of the order of operations. So our goal in this problem is to isolate the variable x. Sometimes we say get x by itself. So first we determine what's been done to x. In this case, x has been multiplied by 2, and then 5 has been added to it. We want to do the inverse, or opposite operations. So first we want to do the opposite of adding 5, so we're going to subtract 5. It's very important when solving equations to always do the same things to both sides of the equation. That's the only way to make sure both sides of the equal sign say equal. So we subtract 5 on both sides of the equation. Now we want to do the inverse operation of multiplying by 2, so we're going to divide both sides of the equation by 2. This gives us a solution to the equation with x being equal to -7. Now the great thing about solving equations is that we have a built-in way to tell if we did it correctly. We do that by checking our answer. The first step is to rewrite the original equation. Then we substitute in the answer we got, in this case -7, for the variable x. Then we simplify. Since both sides of the equation end up being equal, we know our solution was correct. Let's try another example. Again, our goal is to isolate the variable y in this case. We notice that y has been divided by 3 and then 8 is subtracted from it. We're solving this by doing the inverse operation in the reverse order of operations. So we're going to do the inverse of subtracting 8 first. So our first step is to do the opposite of subtracting 8. So we add 8 to both sides. Now we want to do the opposite of dividing by 3, so we're going to multiply by 3. Again, notice we multiply both sides by 3. This gives us our solution, y equals 6. Are we finished? Nope, we can check our solution by rewriting the original equation. Then substituting in 6 for y. Then simplifying. Our solution is correct since both sides of the equation are equal. In this third example, notice how the variable is on the right side of the equation. While this looks different, we approach it in the same way. But also note that there are some like terms on that right side, so our first step is to combine any like terms we find, in this case 5k and -9k. Now we look at our variable k and notice that it's been multiplied by -4 and then had 17 added to it. We want to do the inverse of adding 17, so we're going to subtract 17. Now we're going to divide by -4. When we simplify this, we get 5/2. You could also write this as 2.5, but typically in algebra we leave our answers as fractions in simplest form. Once again, we check our answer by rewriting the original equation, then substituting in our answer, and simplifying. Our solution checks. Technically, this is more than a two-step equation, but hopefully you'll forgive me. Now for our guided practice section, we're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step, I'm going to prompt you with the question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So for this problem, our first question is, what are we trying to do here? You should have responded with trying to isolate x, or perhaps get x by itself. Your next question is, what operations have been performed on x? You should have responded with x has been multiplied by -5 and then 8 has been subtracted from it. So what should we do next? We should do the opposite of subtracting 8, so we're going to add 8 to both sides. Now what? We should do the opposite of multiplying by -5, so we're going to divide by -5. Are we finished? No, we should check our answer. How do we check our answer? We start by rewriting the equation. Then what? We substitute in our answer, in this case -3 for x, and simplify. Let's go through that process again with a new problem. What are we trying to do? Isolate the variable d. What operations have been performed on d? It's been divided by 4 and then had 12 added to it. So what do we do first? We subtract 12 from both sides. Now what? We're going to multiply both sides by 4. Are we finished? No, we should check it. How do we check it? Rewrite the equation. Now what? Substitute our answer, -20, in for d, then simplify. Our solution works. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video and work out the problem, then press play to check. Here's the solution and the check. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same procedure on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Pause the video now. Here's the solution and our check. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to solve two-step equations. We did that by performing the inverse, or opposite, operation in the reverse order of operations. Remember that you can always go back and replay portions of this video if you need to see it again.